In a daring announcement that has sent ripples throughout the scientific community, NASA revealed the discovery of a celestial body unlike anything we have previously encountered. This newly studied dwarf planet not only astonishes with its size and position in the asteroid belt but also because of mysterious bright spots on its surface that emit light, some scientists say almost appearing artificial. Are these glowing patches natural phenomena? Or could they be signals of something far more extraordinary? This discovery raises profound questions. Are we on the verge of uncovering secrets that could radically transform our understanding of the universe? Could this signal the presence of life or complex geologic processes on other worlds? To explore these incredible findings, we turn to NASA's Dawn spacecraft, a mission that has revolutionized planetary science since its launch in 2007. Dawn was built with an innovative propulsion system powered by 3 ion engines, making it the first spacecraft capable of entering and leaving the orbit of multiple celestial bodies. This advanced technology allowed Dawn to explore 2 of the most fascinating and ancient bodies in the solar system, Vesta and Ceres. Dawn's journey began with a 14-month detailed study of Vesta, the second largest object in the asteroid belt. During this phase, the spacecraft transmitted detailed images and scientific data revealing Vesta's rugged surface marked by gigantic craters, ancient lava flows, and evidence of a differentiated interior, meaning it once had layers like Earth with a core, mantle, and crust. These findings provided critical insights into the early solar system's formation and the processes that shaped planetary bodies. After completing its mission at Vesta, Dawn embarked on the second and most anticipated leg of its journey, an exploration of Ceres, the largest object in the asteroid belt and the only dwarf planet located in the inner solar system. Thanks to its ion propulsion system, Dawn was able to leave Vesta's orbit and make a slow but steady approach toward Ceres, a feat impossible with conventional chemical rockets due to fuel limitations. Ceres was discovered in 1801 by Italian astronomer Giuseppe Piazzi, initially classified as a planet before being reclassified as an asteroid and then finally as a dwarf planet in 2006. With a diameter of approximately 950 kilometers, Ceres is both the largest and most massive body in the asteroid belt. Scientists have long been intrigued by Ceres because its size and composition set it apart from typical asteroids. Unlike rocky or metallic asteroids, Ceres appears to have a more comet-like constitution with a substantial amount of water ice and hydrated minerals on its surface. The excitement in the scientific community grew as Dawn's instruments began sending back images of Ceres' surface. Early low-resolution pictures hinted at a complex world, but it wasn't until high-resolution images arrived in 2015 that the mystery of the bright spots was unveiled. Scattered across the surface, particularly within the Achater crater, these glowing patches reflected sunlight with remarkable intensity, standing out sharply against the otherwise dark, dusty terrain. The nature of these bright spots sparked immediate debate and intense research. Initial hypotheses ranged from simple ice patches to deposits of highly reflective salts. However, further analysis using spectrometers aboard Dawn revealed that these bright areas were primarily composed of sodium carbonate, a type of salt commonly found in hydrothermal deposits on Earth. This was a stunning revelation. It indicated that the material had likely been deposited by liquid water that had somehow made its way to the surface from beneath Ceres' crust. This discovery strongly suggests that Ceres is not a dormant, lifeless rock but a geologically active world with ongoing processes beneath its surface. The presence of sodium carbonate points toward cryovolcanism, a rare type of volcanic activity where instead of molten rock, volatile substances such as water, brine, or ammonia erupt from beneath the surface. As these salty liquids reach the vacuum of space, they quickly sublimate, turning directly from liquid to gas, leaving behind reflective salt deposits that form the mysterious bright spots. Such geological activity challenges earlier assumptions that Ceres was inert. Instead, it paints a picture of a dynamic world where internal heat, likely generated from radioactive decay of elements such as potassium-40 and thorium-232, keeps pockets of briny water liquid beneath a crust of ice and rock. Scientists speculate that Ceres may harbor a subsurface ocean or layers of liquid brine beneath its surface, perhaps hundreds of kilometers thick. This possibility has enormous implications. Water is considered essential for life as we know it, and where there is liquid water, there is the potential for life to exist. While no direct evidence of life has yet been found on Ceres, the combination of water, salts, and organic molecules detected on its surface suggests that conditions could be favorable for microbial life or at least prebiotic chemistry. Moreover, Dawn observed transient hazes or plumes near a crater, faint, fog-like clouds that are thought to be water vapor escaping from sublimating ice or brine deposits. These plumes imply that cryovolcanic activity may still be ongoing or has occurred recently on geological timescales. Ceres even appears to have a very thin atmosphere or exosphere, composed mostly of water vapor and possibly other gases, that varies with solar heating. Further adding to the intrigue is the discovery of organic molecules on Ceres' surface. These carbon-based compounds are the building blocks of life, and their presence alongside water and salts makes Ceres one of the most promising places in our solar system to study habitability outside Earth. While these scientific findings alone are groundbreaking, the nature of the bright spots has also led to some public speculation and imaginative hypotheses. The unusual brightness and somewhat geometric patterns in the Achater crater have led some to wonder whether these could be artificial structures or signs of alien technology. Though mainstream science remains highly skeptical and attributes these patterns to natural geological processes, the discussion highlights how much we have yet to learn about the cosmos. From a planetary formation standpoint, Ceres' unique internal structure sets it apart. Its core is believed to be a mixture of rock and brine, while its mantle contains a mixture of ice and hydrated minerals, including clays and carbonates. This composition makes Ceres less dense than many neighboring asteroids and more similar to icy moons such as Europa or Enceladus, known for their subsurface oceans. Scientists also think that Ceres formed farther from the Sun in the colder outer solar system and migrated inward over time. This theory is supported by the presence of ammonia-bearing minerals on its surface, as ammonia can lower the freezing point of water, making liquid brines more stable. The study of Ceres offers insights not just about the dwarf planet itself but also about the early history of the solar system. It serves as a window into the processes that shape planetary bodies and the distribution of water and organic materials throughout the solar system. Understanding these processes helps us better grasp how Earth might have acquired its water and the conditions necessary for life to emerge. Looking to the future, scientists and space agencies are considering follow-up missions to Ceres, which could include landers or even rovers equipped to drill beneath the surface. These missions would aim to directly sample the subsurface ocean and analyze the chemistry for signs of life. In addition, Ceres' abundant water ice makes it a potential resource for future human space exploration. Mining water from Ceres could provide life support and fuel for missions further into the solar system, making it a critical stepping stone for humanity's expansion beyond Earth. In the grand tapestry of the cosmos, Ceres stands as a beacon, an icy, enigmatic world that challenges our definitions of planets, moons, and asteroids. It invites us to ask deeper questions about habitability, planetary evolution, and the possibility of life beyond Earth. As NASA's Dawn mission has shown, the solar system is filled with wonders waiting to be explored, mysteries waiting to be unraveled, and surprises waiting to change our understanding of the universe forever. If you enjoy these cosmic journeys and want to stay updated on the latest space discoveries, make sure to subscribe to Discovery at 2.0, hit the notification bell, and join us as we continue exploring the mysteries of the universe. Thank you for watching, and I'll see you in the next video.